Hello guys, season greetings to everybody. Today I have another phone, which is Vivo Y02, which backlight problem. After a water damage issue, the phone is working. The phone will turn on. You will feel the vibration after the power button was pressed, but there's nothing on the screen, no image and no backlight. So I've checked the location of the backlight circuit, so I have to cut out the metal shade so that I can check the backlight circuit. So there's a couple of ways to do this to remove the shade, but for me, and especially on this phone, I have to cut it out like this because you can see the CPU, or let me say those components under the metal shade, like the CPU and others, they have gum under, like glue under. And if you want to use a workstation to remove the metal shade like this, in the process of eating the metal shade, those components will get affected, and at the end of the day maybe the phone will not turn on again. And to fix the problem is even more hard because you have to remove all the CPU, as in all those components, clean it, reball it again, stuff like that. So that's very long, and I'll just consider that highly risk. So for me to cut it out like this is safer, very safe. You can see within 1 minute or less than a minute I've cut it out and I've revealed the backlight circuit. So after I've cleaned the flux, because this phone has been worked on by another technician before, so you can see the flux around. Maybe when they try to fix the water damage, they, like normal, they will clean it with a chemical, and when they discover that the phone is not having backlight, they have to, like normal, they have to eat it, but still that's not the point. So now this is the this is the backlight IC. Typically this is what you will find in most Android phone. You have an IC with 6 legs. From the 6 legs, we have inputs, we have outputs, and we have enable pin. Then we have ground, we have the cathode leg, which is for the negative side of the backlight. Then we have no connection. So the inputs is connected to pH line, which is around 3.7 to 4.0, stuff like that. And the output is usually higher, ranging from 15 volts to 24 volts. It depends on model of the phone. And the enable pin, which is the one at the middle, usually have sometimes 1 voltage or 1.8. It depends on model too. And that enable signal come out from CPU. So I have to check all these pins and see if everything is okay. Now after I check the input and I check the enable pin. There's normal voltage on the input, and the enable pin, there's I think 1 voltage there too. That means the connection is okay, because there won't be enable signal if the CPU does not detect screen. For a phone to have enable pin on the backlight IC, it means the phone, the CPU detected that there is a screen connected to the phone. So now I have to check other things. Now I discovered that one of the pin on the screen connector have corroded due to liquid damage. So I have few options here. I can remove the connector, the screen connector on the motherboard, repair the corroded pin and replace the connector, but I found it risky because there's other way I can use, there's other safer way that I can use to solve this problem, which is I have to trace the connection on the screen itself. So you can see how I scrape that part. That is the pin that is connected to the backlight circuit. So I have to run a jumper wire from the screen to the output of the backlight circuit, and with that I believe that one is safer. It doesn't create any more problem, and of course the principle of repairing mobile phone or any device is to create a solution that does not create another problem. So now, even to replace the screen, any technician can replace the screen again now, because they have already seen the connection. They can just return the connection and the phone will always work. So this is the output of the backlight. So now I'm securing it with tape to avoid short circuit. Now let me test. Oh yeah, now we have the backlight and image on the screen. So problem solved.